He was ahead of his time. He created a weapon that could wipe out entire armies from the face of the earth. A machine gun that decided the outcome of battles. And who invented it? A doctor and a pacifist? How did the first rapid-fire weapon work? Why did generals fear it? And how do its principles remain relevant to this day? Gatling Gun, the weapon that changed warfare. Let's break it down in detail. The year is 1862. The United States is in the midst of the Civil War. Infantrymen are still using muskets, reloading them for 20 to 30 seconds per shot. Generals dream of turning the tide of battle, but the right weapon simply doesn't exist. Then, one of the most revolutionary firearms in history emerges, the Gatling Gun, the world's first multi-barrel rapid-fire system. This weapon could transform a unit into an impenetrable wall of gunfire. It fired faster than anyone at the time could pull the trigger and changed the course of military conflicts forever. And here is its creator. Meet Richard Gatling. Richard Jordan Gatling was born in 1818 in Hertford County, North Carolina, USA. His family were wealthy farmers who grew tobacco and cotton. But his father, Jordan Gatling, was not only a farmer, but also a talented, self-taught mechanic who gave his son an interest in engineering. Since childhood, Richard was interested in mechanisms. He observed how agricultural equipment worked, and by the age of 18, he had already developed his own model of a screw-propelled paddle wheel for steamboats. However, he soon learned that a similar design had already been patented, a valuable lesson in the world of invention. As a young man, Gatling enrolled at Ohio State University, where he studied engineering and agriculture. But he never completed his degree. He chose hands-on experience instead. In 1839, he designed an improved plow, and in 1844, he patented a rice planter that greatly simplified farming. This invention made him well-known in agricultural circles, prompting him to move to Indiana, where he established his own company, producing farming equipment. However, his true fame came with the invention of a wheat planter in 1850. This machine could simultaneously dig furrows, plant seeds, and cover them with soil, significantly increasing efficiency. So why did this agricultural engineer turn to weapons? Yes, Gatling was a successful agricultural inventor, but his mind was not confined to a single field. When the Civil War broke out in the US in 1861, he began thinking about how to reduce human casualties in battle. Ironically, Gatling was not a supporter of war. He believed that if armies had weapons capable of replacing thousands of soldiers, it would reduce mobilization in large-scale conflicts. This idea led to the birth of multi-barrel rapid-fire weaponry. In 1862, Gatling received a patent for his invention. The first working prototype featured 6 barrels rotating around a central axis. Unlike later automatic weapons, the Gatling gun did not use gunpowder gases for operation. The shooter had to manually turn a crank to activate the mechanism. The essence of the work was as follows. Several barrels, ranging from 6 to 10, depending on the model, were mounted on a central rotor. A top-mounted magazine, either box or drum, held 100 to 200 rounds. Using gravity, the bullets dropped into the chamber. By turning the crank, the shooter activated a mechanism that sequentially loaded rounds, fired them, ejected the spent casings, and chambered the next rounds. Because multiple barrels were used instead of just one, the weapon could fire longer without overheating. The earliest models had a fire rate of 200 rounds per minute, an unheard-of figure for the 19th century. Later versions, with improved cartridges, reached speeds up to 600 rounds per minute. Here are the specifications of the Civil War-era Gatling gun. Caliber: 58, 14.7 mm, or 45-70 government, 11.43 mm. Weight: 80 to 200 kilograms, depending on the model. Length: about 1.2 to 1.5 meters. Operation: manual, mechanical. Rate of fire: 200 to 600 rounds per minute. Effective range: up to 800 meters. With the transition to metallic cartridges, the system's reliability significantly improved. By the 1880s, electrically powered versions emerged, allowing for sustained fire without manual operation. So, did Gatling Gun help end the Civil War? Unfortunately, no. Gatling attempted to sell his invention to the Union Army, the Northern Forces, but military leadership was hesitant. Armies were still reliant on traditional rifles and artillery, and generals feared that widespread adoption of this new weapon would require drastic tactical changes. However, by the 1870s and 1880s, both the British and American armies began using the Gatling gun extensively in colonial conflicts. The British purchased Gatling machine guns in 1874 for use in Africa. During the Battle of Ulundi in 1879, 2 Gatling guns provided British forces with an enormous advantage against the Zulus, who were primarily armed with spears and shields. When about 20,000 Zulus attacked, the British opened concentrated fire with rifles, field artillery, and machine guns. The Zulus were unable to break through the British lines and were almost destroyed. The British military highly appreciated the new weapon. Moreover, in the 1870s, the British Arms Manufacturing Company even began producing copies of the weapon for export. Some of these made their way to Russia, where they were used during the Russian-Turkish War of 1877 to 1878 under the name Gatling rapid-fire guns. However, the Gatling gun did not gain widespread use in Russia. First, because of the complexity of maintenance. The large number of moving parts required a trained team. Secondly, there were problems with cartridges. Russia had not yet completely switched to metal unitary cartridges, which reduced the reliability of the system. And already in the 1890s, Russia bought his fully automatic machine gun from the Briton Hiram Maxim, which turned out to be much more effective. By the way, is it true that without the Gatling there would be no Maxim? Quite possibly. The Gatling gun was a direct predecessor to Hiram Maxim's invention, and also for the first time demonstrated the principle of a high-velocity armored vehicle capable of conducting a desperate fire at the enemy. What did Maxim borrow from Gatling? The idea of a multiple-shot weapon. Before Gatling, militaries relied on single rifles and artillery, but the Gatling gun proved that rate of fire was the key to battlefield dominance. Ammunition feeding mechanisms. Both systems used magazines or belts instead of loading rounds one by one. The concept of continuous fire. The Gatling gun could fire longer than soldiers with rifles, but required manual cranking. Maxim went further and made this process automatic. The Gatling gun required manual rotation, while Maxim used the recoil energy to operate the bolt and feed the cartridges. In other words, the shooter simply pulled the trigger, and the machine gun did everything else on its own. Maxim's gun wasn't a copy of the Gatling gun, but rather an evolution of the concept, inspired by its predecessor. So that's it? The Gatling gun revolutionized warfare, lasted for 2 decades, and was then replaced by a more advanced successor? It would seem so. But no, the principles of the Gatling gun still live on today. The Gatling gun became obsolete as a weapon in the early 20th century, but its operating principles not only survived, they became the foundation for the most powerful rapid-fire systems of the modern era. The key reason? The concept of rotating barrels. This design allows for increased rate of fire. The more barrels, the higher the firing speed, as each successive shot is fired from a cooled barrel. It reduces overheating. If a single barrel fired at a rate of 4,000 to 6,000 rounds per minute, it would quickly overheat. But with multiple barrels, the heat is distributed. It also ensures reliability. The rotating mechanism prevents jamming, which is critical for aviation and naval weaponry. As a result, modern rapid-fire cannons and machine guns continue to use the Gatling-style multi-barrel design. A prime example is aircraft weaponry. In aviation, a high rate of fire is essential for engaging both aerial and ground targets. A single barrel could not withstand such an intense firing rate without overheating. The rotating mechanism enables sustained, rapid fire with minimal delays. Take this example. In the 1960s, the US realized its forces needed a ground attack aircraft with a powerful weapon to counter Soviet tanks. The problem? Standard aircraft cannons could not penetrate Soviet tank armor. And here you are, in 1970, General Electric developed a monster, GAU-8 Avenger, a 30mm 7-barrel aircraft rotary cannon designed for the American A-10 Thunderbolt II attack aircraft. This is an incredibly powerful aviation weapon, capable of destroying tanks and enemy vehicles in mere seconds from a distance of up to 1.5 kilometers. It is also the largest aircraft cannon ever mounted on a combat plane. Its size is so immense that the A-10 was literally built around the GAU-8. Otherwise, the weapon simply wouldn't fit. Where was the GAU-8 used? Gulf War, 1991. A-10s destroyed over 900 tanks, 2,000 armored vehicles, and 1,200 artillery positions. Iraq, 2003 to 2011. Used for troop support and enemy vehicle destruction. Afghanistan, 2001 to 2021. Employed for strikes against Taliban positions. The GAU-8 Avenger is not just an aircraft cannon, it's a true death machine for tanks and armored vehicles. And then there's the M61 Vulcan, a legendary U.S. aircraft cannon developed in the 1940s and still serving as standard armament on American fighter jets for over 60 years. This 6-barrel, 20mm rotary cannon combines insane firepower, up to 6,000 rounds per minute, reliability, and compactness, making it the perfect weapon for air combat. Unlike the Gatling Gun's mechanical operation, the Vulcan uses an electric drive. The M61 Vulcan produces a barrage of fire that is capable of blowing up an enemy aircraft or destroying a ground target in seconds. In classic dogfights, air battles, missiles are not always effective, and that's where the Vulcan comes into play. Its high rate of fire allows pilots to instantly tear apart an enemy fighter, even if it's maneuvering. The M61 Vulcan is used on F-16s and FA-18s to destroy light vehicles, trucks, air defense systems, and fortifications. Combined with precise targeting, pilots can burn down enemy positions and ground attacks. The M61 Vulcan was used in the Vietnam War, 1955 to 1975, mounted on F-4 Phantom II, F-105 Thunderchief, and AC-130 for air-to-ground strikes and aerial combat. A pod-mounted version, the SUU-23A, was developed for aircraft without built-in cannons. In the Gulf War, 1991, the F-15 and F-16 used the Vulcan to eliminate Iraqi aircraft. The Phalanx CIWS intercepted enemy missiles and planes, and Iraq and Afghanistan, 2001 to 2021, used in airstrikes and troop support. F-16s and FA-18s deployed the Vulcan against terrorists and light vehicles. The M61 Vulcan remains the primary aircraft weapon of American fighter jets. GShG-7.62, USSR, Russia, a Soviet counterpart to the Vulcan, but with insane firepower. The GShG-7.62 is a 30mm 6-barrel cannon used on the MiG-27, Su-25, and naval vessels, boasting a rate of 5,000 rounds per minute. After the Korean War, it became clear that Soviet aircraft needed a high rate of fire cannon. At the time, the US had already begun developing the M61 Vulcan, so the USSR decided to create an even more powerful and robust alternative. Thus, the GShG-7.62 was born, designed for both Soviet aviation and naval defense. This beast rips enemy targets apart with its immense kinetic energy. The MiG-27 used the GShG-7.62 to destroy tanks, armored vehicles, and artillery. It remains in use today on Russian Navy ships. In short, the GShG-7.62 is the most powerful rapid-fire aircraft gun in the USSR. However, the GShG-7.62 has notable drawbacks: massive recoil. The MiG-27 shook so violently during firing that pilots lost control. Large ammunition size. Fewer rounds could be carried compared to the M61 Vulcan. Complex design. Rarely used in aviation due to installation challenges. Shipborne anti-aircraft systems also use the Gatling principle. Rotating barrels allow them to target supersonic missiles and aircraft, creating a powerful defense line. The rate of fire is also crucial. You need to hit the target in seconds. Take, for example, the Phalanx CIWS, USA, a 20mm six-barrel system installed on NATO ships to destroy missiles and drones. This American shipborne supergun against missiles and drones was developed by General Dynamics in 1969 and adopted into service in 1980. After World War II, it became clear that ships needed automatic air defense systems. The Vietnam War demonstrated that anti-ship missiles, especially Soviet ones, posed the greatest threat. The US decided to develop a fast, autonomous, and deadly defense system, and the Phalanx CIWS was born, the shipboard equivalent of the M61 Vulcan automatic turret. Its operation is fully automatic. It detects, tracks, and destroys targets without human intervention. Initially, the radar identifies a threat: missile, drone, aircraft. The system then automatically locks onto the target. Fire opens at a rate of 6,000 rounds per minute. And that's it. The enemy is destroyed in a fraction of a second. The Phalanx CIWS activates when anti-ship missiles, such as the Musket or Harpoon, approach. It creates a continuous kill zone in front of the ship. It is capable of destroying supersonic targets flying at altitudes of 5 to 50 meters. Where has the Phalanx CIWS been used? In the Falklands War, 1982. After this war, Great Britain began installing Phalanx on its ships. During Operation Desert Storm, 1991, Phalanx protected U.S. aircraft carriers and destroyers from Iraqi attacks. In Iraq and Afghanistan, 2001 to 2021, the ground version CRAM destroyed missiles and mortar shells flying toward American bases. Even today, the Phalanx CIWS is used to defend fleets against hypersonic missiles and drones. Disadvantages of Phalanx CIWS: its short range, up to 1.5 kilometer. It cannot intercept missiles with a greater radius. It cannot be reloaded during battle. Once the 1,550 rounds are exhausted, time is needed for reloading. Now, the AK-630, Russia, an analogous shipborne anti-aircraft system using a 6-barrel, 30mm gun with the rate of fire up to 5,000 rounds per minute. This is the main Russian equivalent of the American Phalanx CIWS, designed to protect ships from missiles, aircraft, and small vessels. Essentially, the Soviet defense industry decided to use the GShG-630, a 30mm aircraft gun, in a naval variant, and in 1976, the AK-630 was created. Its firing range is up to 4 kilometers against air targets and up to 5 kilometers against surface targets. It uses hydraulic drive plus automatic targeting. The AK-630 was used in the Yemeni Civil War, 2015. Russian and Chinese ships used the AK-630 to defend against drones and missiles from the Houthis. During the conflicts in Syria, Russian Navy ships equipped with the AK-630 protected the aircraft carrier Admiral Kuznetsov. Currently, the AK-630 is actively used in the Black and Baltic Seas. It is used against drones and sea drones. Disadvantages include an outdated fire control system. It needs upgrading and might fail to intercept hypersonic missiles. Also, its weight of 1,850 kilograms makes it harder to install on smaller ships. Goalkeeper CIWS, Netherlands, an improved version of the Phalanx with increased range and accuracy. After the advent of Soviet supersonic anti-ship missiles, such as the P-270 Musket, NATO realized that ships needed powerful, high rate-of-fire defense systems. The Netherlands decided to create a more powerful alternative to the Phalanx CIWS, using the 30mm GAU-8 Avenger gun, the same one used on the A-10 Thunderbolt II. Its firing range is up to 2 kilometers. The guidance system uses dual radar, search plus tracking. The Goalkeeper has much more powerful shells than the Phalanx CIWS and hits targets with a higher probability. It detects targets with radar at distances up to 30 kilometers, tracks them, calculates the trajectory, and opens fire, 70 rounds per second. That's it. The missile, drone, or aircraft is torn apart. Additionally, the Goalkeeper can destroy supersonic missiles flying at low altitudes. Thanks to the 30mm caliber, it can destroy targets with the first volley. Dutch ships use the Goalkeeper to defend against drones from the Houthis in Yemen. It is currently used on NATO's largest ships and remains the last line of defense against modern threats. And what about land-based descendants of the legendary Gatling gun? Of course, how could we do without land-based systems? Armored vehicles, air defense, and base defense. Rotating barrels allow for powerful suppressive fire against infantry, drones, and vehicles. The high density of fire makes Gatling-based systems effective against swarms of drones and lightly armored targets. M134 minigun is an American 6-barrel machine gun chambered in 7.62 51mm NATO, capable of firing up to 6,000 rounds per minute. It is one of the most recognizable and lethal machine guns in the world, known from films, video games, and military operations. After the Korean War, 1950 to 1953, the US military realized that traditional machine guns, like the M60, lacked the necessary rate of fire for airborne and transport platforms. The solution was clear. Take the concept of the Gatling gun, reduce the caliber to 7.62mm, and make an electrically driven machine gun. Thus, the M134 minigun was born, a machine gun that can shoot faster than a person can process what's happening. The creation of General Electric, it was adopted into service in 1963. The M134 minigun is used on helicopters and airplanes, ground vehicles, in special forces, and the Marine Corps. It is deployed in stationary positions and for base defense. Interestingly, movies show it being fired from the hand, but in reality, that is impossible without mounting. Its high rate of fire makes it perfect for combat against infantry and lightly armored vehicles. US Special Forces use the minigun to create dense, suppressive fire. It can mow down entire rows of enemies in just a few seconds. The M134 minigun was first used in the Vietnam War, 1965 to 1975. UH-1 Huey helicopters turned the jungles into a meat grinder with the minigun. Soldiers nicknamed it Zippo because it burns the enemy instantly. During Operation Desert Storm, 1991, it was used on AC-130s and Special Forces helicopters. In Iraq and Afghanistan, 2001 to 2021, it was one of the main machine guns on the Black Hawks and special units. Of course, the minigun is still used by the US and NATO for air support. The Soviet GShG-7.62, USSR Russia, is a 6-barrel machine gun chambered in 7.62 54mm, created as the Soviet equivalent to the American M134 minigun. It was developed for equipping Soviet helicopters and special units, but it had an important difference. It operated on a gas-operated system rather than an electric drive. This powerful, high rate of fire weapon is capable of firing up to 6,000 rounds per minute, but without the need for electric power. Adopted into service in 1972, the GShG-7.62 was used on helicopters, armored vehicles, and turrets, and was employed in Afghanistan to defend bases, as well as mounted on stationary points for fire support. Mi-24 helicopters used the GShG-7.62 for clearing enemy positions. A 2-second burst would turn enemy cover into Swiss cheese. Mi-24s armed with GShG-7.62 were a nightmare for the Mujahideen. It was used to suppress ambushes and destroy caravans. Special Forces used the GShG-7.62 for clearing buildings and fortified positions. During the Russian-Chechen Wars, Mi-24 helicopters armed with the GShG-7.62 were used to support Special Forces and clear mountainous areas. Sea Vulcan is the naval version of the American M61 Vulcan 6-barrel aircraft gun, designed to protect ships from drones, small boats, and airborne threats. It is a high rate of fire automatic system providing close-in protection for ships, operating on the CIWS Close-In Weapons System principle. This naval minigun fires 100 rounds per second and can destroy attacking targets in fractions of a second. After the success of the M61 Vulcan aircraft gun, the US began thinking about adapting it for use on ships. At the time, the main threats were small maneuverable boats, drones, and attacking aircraft. The Sea Vulcan fires bursts, creating a fire barrier around the ship. It can intercept low-flying aerial threats in the last kilometers. It is used in conjunction with anti-aircraft missiles. It is deployed at strategic maritime points to protect against terrorist attacks. The Sea Vulcan showed its capabilities during the Gulf War, 1991. It was used on patrol boats to destroy Iraqi fast attack boats. It protected naval bases from drone and small boat attacks in Iraq and Afghanistan. It is still in use today to combat drones and sea drones in strategic ports. But that's not all. Military engineers are expert in stating that the Gatling principle will play a role in the weapons of the future. Gatling-style rotating mechanisms are used in laser complexes, where each barrel is a separate laser module. Overheating is a fundamental issue for laser weapons. The laser module generates a lot of heat. The rotary system allows alternating between laser modules, reducing the load on each of them. This increases the rate of fire. One laser charges while another is firing. Efficiency is maintained for a longer period. While in classic machine guns, the Gatling principle solves the problem of barrel overheating, in laser weapons, it addresses the issue of energy generation and dissipation. Here are some prominent examples. Rheinmetall HEL, High Energy Laser, is a multi-barrel laser system developed by the German company Rheinmetall. It's a groundbreaking technology in the field of laser weaponry, using a rotary principle, similar to the Gatling gun, to destroy drones, missiles, and aircraft. It's one of the most advanced combat lasers in the world, capable of destroying targets at the speed of light. With the advent of drones, hypersonic missiles, and other modern threats, it became clear that traditional air defense systems, anti-aircraft missiles, and CIWS machine guns cannot react fast enough to the new speeds of attacking targets. And here it is, the solution: creating a laser system that can instantly hit ultra-fast objects while using a multi-beam working principle, laser Gatling. Main characteristics of the Rheinmetall HEL: power, from 50 to 100 kilowatts, with future potential of 500 kilowatts or more. Effective range, up to 3 to 5 kilometers. In the future, over 10 kilometers. Guidance system, automatic targeting with optical sensors and radars. Operating, multi-module rotary system, similar to the Gatling gun. Targets, drones, missiles, mines, artillery shells, helicopters, and light armored vehicles. How does the Rheinmetall HEL work? Radar or optical sensors detect the approach of a target, drone, missile, artillery shell. The computer control system targets the laser at the object and starts tracking its trajectory. A quick shot, the laser vaporizes the drone's casing or burns through the missile's warhead. The rotary principle, similar to Gatling gun, allows alternating between laser modules to avoid overheating. The drone, missile, or shell loses its aerodynamics, catches fire, or explodes in midair. Rheinmetall HEL has not yet been used in combat, but active trials are ongoing. It's expected to be adopted in the 2030s. Meanwhile, tests have shown that HEL can destroy drones at altitudes above 3 kilometers, intercept mines and artillery shells before they hit their target, and deal with small missiles and drones at high speeds. At the same time, the Americans are working on creating DARPA HELADS, a promising American laser system in which the Gatling principle is used for cooling. HELADS, High Energy Liquid Laser Area Defense System, is an experimental combat laser developed by DARPA for installation on fighter jets, drones, and ground-based armored vehicles. It's one of the most compact and powerful combat lasers, using a unique liquid cooling system to reduce overheating and allow continuous fire. Main characteristics of HELADS: power, up to 150 kilowatts, with future versions 300 plus kilowatts. Size, 10 times smaller than other lasers of similar power. Weight, less than 750 kilograms, which allows installation on fighters and drones. Operating principle, liquid cooling plus multi-beam principle, similar to Gatling gun. Targets, missiles, drones, aviation, artillery shells, air defense systems. Tests from 2015 to 2020 have shown that HELADS can destroy drones at altitudes above 3 kilometers. and intercept artillery shells and missiles. It can even be used for aerial duels between aircraft. DARPA Hellheads has been undergoing testing since 2015, and its adoption into service is expected in the 2030s. How would Richard Gatling have reacted to such a weapon? Well, what can be said? The Gatling gun was the first step toward modern automatic weapons. Its operating principle was revolutionary, and its effectiveness deadly. Richard Gatling's idea may have been aimed at reducing casualties, but as we can see, humanity has used it in quite a different way. Although the Gatling machine gun itself is now a thing of the past, its principles live on in aviation, the Navy, and ground systems. Today, they enable the destruction of air, ground, and sea targets with astonishing speed and power. Without the Gatling gun, there would be no modern aircraft guns, miniguns, or shipborne CIWS. In the 21st century, even laser systems borrow the rotary design to increase efficiency.